Alright, so this is slope of parallel and perpendicular lines. Notes. These set of notes are more of a review than anything, but it's a review that y'all definitely need, just due to past experience, like I always talk about. Because in this chapter, we need to learn how to write equations of parallel and perpendicular lines. But to be able to do that, y'all need to know how to find slopes of parallel and perpendicular lines. This is an algebra skill, but it either may have been not taught or taught to you, and maybe you weren't there, or maybe you didn't process it, or maybe you already know it. Hopefully you're in that category. You already know, and this is just really a review for you. But if it's not, gain some knowledge today. Slope review. Classifying slopes. Yeah, 4 different lines here with different slopes. You should just know by looking at a line what kind of slope it has. So, looking at this first line, and when we say what kind of slope, is the slope positive? Is it negative? Does it have a slope? Or is the slope undefined? That is the question. Looking at this first line, and the way we read slope is from left to right, the way we read anything. From left to right, I see this line is going up. In that case, this line would have a positive slope. Does this pen work? Oh, this pen is dry. Positive. From left to right, this next line going down. Negative slope. I know these things without even knowing any numbers or anything. I could just look at the line and tell what kind of slope it's going to have. Oh, this next line is completely horizontal. Line is horizontal, that means you basically have no change in your x values. Your y values change, but your x's don't. This is zero slope. This next line is completely vertical. This means we have no change in our y values. Our y values stay the same. But our, hold on, am I saying that right? No, we have no change in our x values. X values stay the same, but our y values change. This is undefined. So zero slope, horizontal line, undefined vertical line. Alright. Next thing, finding slope. Given a graph, if you wanted to find slope on a graph, all you would do is use what y'all know as rise over run. And we've done that already. When we've been making those triangles for Pythagorean theorem, we were basically drawing rise and run triangles. That's what that is. So when we were doing distance and we were using the Pythagorean theorem and making our triangles, those triangles were helping us find slope, rise over run. But they also helped us find the distance between 2 points too, if we used them in Pythagorean. Alright. Given an ordered pair, we would use m, lowercase m, equals y2 minus y1 over x2 minus x1. This is how we find slope. Change in y over change in x. Basically a change in your rise over your change in your run. Y2, I mean the y's are the rise because that's your vertical. Horizontal is your run because that's your horizontal. The x is your run, excuse me. Alright. Number 2 down here. Oh, no, we're skipping 1. I'm tripping. So 1 on the graph, you got points A and B on the graph. And they want us to find slope. So to find slope, easiest way, I go from point A to B and make my triangle like we've been doing. And then I'm gonna count my rise. Rise is 1, 2, 3, 4. 4 spaces. My run, 1, 2, 3, 4, 5. 5 spaces. So it's rise over run. Only thing you need to ask yourself before you write your slope is if it's positive or negative. Billy, based on this line and the direction it's going, is it positive or negative? Positive. So my slope should be m equals 4 over 5. Rise over run. I rose 4, I ran 5. Alright. Yeah. Oh, and this one, if you can't reduce, then you leave it like that. 4 over 5, y'all should know can't be reduced, so leave it that way. Let's skip and do number 3 first, since it's the same. Let's do that. And we'll come back and do 2. And I'll let you do 4. 3. On this one, they want to know my slope from P to Q. So from point P to point Q here. What happened? Oh. So if you wanted to, you could draw your triangle on top. It's not going to matter. And then mine this way just because of the situation. I'll tell you why I did mine that way. So on this one, my vertical change on my rise was 3. My horizontal change is 1, 2, 3, 4, 5, 6. So the only thing, like I asked Billy on the last one, left to right is your line going up or down. Should tell yourself down. If that's the case, then you know this line is going to be negative. And the thing you could do, what I do, is when I'm counting, like if I'm going from this point to this point, vertically, I know I got to move down. So when I do mine, I'll put a negative right here on my 3 just so I remember that it's supposed to be negative. So I went down 3 spaces. I didn't go up. And that's why that's why I draw my triangle like this on the lines that are going down. On my lines that are rising, I draw it like this. But on this one, I could drop it. This is negative 3 over 6. Cannot leave that like that though. This needs to be simplified. What you gonna divide by, Parker? Or Jeremiah? To simplify this, what are you gonna divide by? What? I can't hear you, man. You know what? My video's going too. Don't mess this up. We divide by 3. Talking about, you know how to simplify a fraction? not making this complicated, man. So negative 1/2. What that's telling me also is that they gave me points P and Q, but if you know how to do slope, if I could reduce like that, it's telling me I could have picked another point on there to count my slope, and I could have had it already reduced. For example, and let me do the triangle in another color so you can see it. Whenever y'all doing this, because we may not always give y'all points to use, you may have to figure out your slope for yourself, and you might have to choose 2 points for yourself. If you're on a line, wherever your line meets at that perfect crossing on the grids, those are points. Like for example, P is at a point on the grid, but the next point on my grid from P actually is right here, where the line touches the actual point. And I could just use that if I wanted to do my slope. And if I do a little small triangle right here and over to this direction, I would be going down 1 and over 2, which is negative 1/2, which is my slope already reduced. Another point would have been here, and you could have seen that your slope from there to there is 1/2 as well. And then that last one would have been Q, and then the slope from there is 1/2 as well. So you're seeing like the slope is the same, I mean, from any 2 points that you choose on the line. Even if you choose the biggest points, though, it'll still reduce down to what it's supposed to be. Like I chose from P to Q when we reduced it down to negative 1/2. But if you choose any 2 points on that line, you can reduce. I mean, you won't have to reduce if you pick the smallest 2, but if you don't pick the smallest 2, just reduce and you'll get the right slope. Alright, moving zones. Find the slope of line GH. This isn't on a graph. They give you just the points. G is at negative 11.3, H is at negative 6.7. When it's not on a graph, when they give you ordered pairs, this is what we want to use, our slope formula. You see, slope formula has the x1, y1 stuff in it, so you know the first thing you should do before you even write the slope formula. How about labeling your points? x1, y1, x2, y2. Then it says m equals y2 minus y1 over x2 minus x1. So I'm putting my stuff in. My y2 was 7 minus sign is already there, and then my y1 is negative 3. Negative 3 x2 negative 6, minus sign is already there, and then a negative 11. This is where you got to be decent with your integers, but you should be. So, what is it? 7 minus negative 3 on top. Y'all should know double negatives would really turn into a plus, so it's really saying 7 plus 3, which will give me positive 10 on top. On the bottom, it's a negative 6 minus negative 11. Got the double negatives inside again, so it's really saying negative 6 plus 11. Negative 6 plus 11 is positive 5. Alright. And then from there, you just need to make sure you reduce if you can. 10 over 5, y'all should all know that can be reduced. Now, naturally you would say 10 divided by 5 is 2. But since we're doing slope, slope always needs to be in fraction form when you're giving slope. So, leave it as a fraction. Reduce it and leave it as a fraction. Y'all should all know we will divide by 5 on top and bottom, but I'm going to show some kids may not know this. Divide by 5, divide by 5. M equals 2 over 1. I'm going to leave it as 2 over 1 because I want my slope to be a fraction. Especially if I'm about to graph. You need slope to be a fraction because you got to have a rise and a run. Do number 4. I want to see what you get. Label. Use the slope formula. If you do it right, be confident in whatever answer you get. Alright. Parker, you say you had the answer? What is it? Yeah, what you got? What was it before that? How you get 1 on the bottom? I mean, what you got for number 4? I mean, did you do number 4? Pick your head up, man. Amber, go ahead. What you got before that? That's important. 6 over 0. I agree with you that it's going to come out to be 0, but depending on where 0 is and if it's on the top or the bottom, that determines what kind of line we have. Because I was talking about it up top, and we may write that in up top. Alright. So for this one, 0 is on the bottom, so that means we had no change in x. If our x values doesn't change, that's when we're going to have an undefined line. So if you have no change in x, yeah, I might want to add that in. No change in x. You're going to have an undefined line. If you have no change in y, that's when you have 0 slope. That's when your 0 will be on top and y. So if there's no change in x, your 0 is going to be on the bottom, your line is going to be undefined. No change in y, your 0 is going to be on top, and you got 0 slope. So on this one, like I said, we got 0 over 6. So I'm going to say m equals undefined. And you see our x didn't change. It was 9 and 9. We did 9 minus 9 and got 0. Anytime your values are the same for, like I said, x, you should know that something, the x value ain't going to change. Same thing for the y. You just got to decide if you 0 slope or undefined. Alright, parallel lines. Getting to the meat of the situation. Parallel lines have the same slope. Perpendicular lines. And I gave this to you in our definitions, but we're going to do it again. Opposite, reciprocal, oh, I ain't spelled something right. Reciprocal. Oh, that's supposed to be an O. Reciprocal slopes. So I wrote that sloppy. I should have wrote a little better than that. R-E-C-I-P-R-O-C-A-L. Reciprocal. Actually, the word is right there on the left. I'm sorry. If you see it down, they say negative reciprocal. We call it opposite. Reason I don't want to say negative with y'all, because y'all think, and kids in the past think that means turn everything negative. That's not what that means. Negative means just negate your sign. I really use opposite because y'all understand that better. Opposite, change the sign. Whatever your sign is, turn it to something else. Alright, so just for practice real quick so you can understand. We don't need to practice on parallel line slopes because honestly, the slopes are going to be the same. That's all you need to know. If you got one slope the one way, then the other slope needs to be the same way. Perpendicular slopes, this is one you need to know because you're going to have to change your slope. It says flip the fraction and change the sign. Jasavian, the first example here says 3/4. If you want to write a opposite reciprocal slope for that, what would it be? It says flip the fraction and change the sign. Jalen, number 6, excuse me. 2. Good. On this one, what Jalen did first, and you can do it yourself if you need to see it. You should understand there's a 1 under 2. Then to flip that, m equals, like she said, negative 1/2. Ty number 7. Say it louder. 8/7. This is you flipping slopes, prepping that to be perpendicular. You're going to have to do this, especially when you write slope equations, especially tomorrow. Make sure you understand this little simple concept of flipping and changing the sign. Onesie back. Says use the slope to determine if lines AB and CD are parallel, perpendicular, or neither. Alright. So what you have here, they give you points on the back, and they're saying these points are representative of line AB and CD. You're going to use those points to figure out if the two lines are parallel, perpendicular, or neither. If the lines are parallel, when you solve for the slope of AB and CD, your two slopes will be the same. And so that means the lines are parallel. They have to look exactly the same though. One can't be positive and negative, and you can't have negative 2/3 and positive 2/3 and say, oh yeah, that's parallel. No, for parallel it has to be exactly the same. Same exact slope, same sign, same fraction, or same whole number, or however you get it. Perpendicular, opposite reciprocals. If it's neither one of those two things, then it's neither. It's neither parallel or a perpendicular line. Alright. So in number 8, I'm going to do 8 with you, and you're going to do number 9, of course, because I ain't doing all the work. Oh, I do these in different colors. Let's do that. So for number 8, I'm going to start out with A and B. I'm going to label those. I'm going to color code too for y'all. I'm going to do my first one in blue and my second one in green. X2, Y2. So I'm only worried about A and B right now, finding the slope for those. So, and if you need to write it at the top of your page, you can on the slope formula, so you don't have to look back. I keep picking up the dead pen. M equals Y2 minus Y1, X2 minus X1. Just putting it up there, or you can put it up there so you remember it. So M equals 6 minus 3, and then over 2 minus negative 2. So when I solved that, my first one, 6 minus 3 is 3. 2 minus negative 2, that's basically adding. So 2 plus 2, 4. My first slope is 3/4. So my slope for line AB is 3/4. Then I go back and I do line CD. X1, Y1, X2, Y2. M equals 3 minus 0 on top, and on the bottom 3 minus negative 1 on the bottom. On top, 3 minus 0 is positive 3. On the bottom, 3 minus negative 1, basically adding again, is positive 4. 3 plus 1. So I get 3 over 4 there. So my two slopes are 3 over 4 and 3 over 4. What type of lines do I have? Say what now? What? Parallel. Based on my slopes, my lines have to be parallel. They are both identical. Do number 9. It depends on how they look, you know, not necessarily. Those are negatives on the bottom. Alright, I'm back. So issue I see with fractions when we're doing this stuff, and maybe I'll just do an example down here in this box where I got room. This is just an example, y'all. So say if you had a slope and it was like, I'm just making these numbers up, 2 minus 5 over 2 minus, let's say, I don't know, 6, it don't really matter. Say if that was the slope you were solving for. And then on top you would get negative 3. On the bottom you get negative 4. That should be a 4, y'all, my bad. So you get double negatives there. What should your slope be? Hold on. It's freaking bells. When you get a negative on top and bottom, like Billy said, your slope should turn positive. It's like dividing a negative by a negative. Drop both negative signs and slope should turn positive. Another situation I see y'all run into, it's another example. Say you have a situation where your slope is, once again I'm making this up, 6 minus 3 on top, on the bottom, I don't know. Hell, let's do this, 2 minus 6 again. For this one, you're going to get 3 on top, positive 3, and then negative 4 on the bottom. Kids like when they write it, or if you have to type that in, kids will write 3/-4. If you only have one negative when you solve, just move that negative to the front of your fraction. Don't leave it on the bottom. It should be in the front. It's not really for the, when you get the negative, like even this one, I know I got this negative up top, but it's really in front of the fraction. It should be out front, negative 5 over 2. So even if your negative is on the bottom, move it to the front. It should be negative, and then the whole fraction should be negative then, 3 over 4. It's not the bottom that's just negative, it's the whole thing. Now if you have double negatives, that's when you drop your signs and turn positive. I need y'all to know that because I see kids on tests every year be writing silly junk, like they'll type an answer in on the computer and that junk will say 3/-4. They're like, what? And they wonder why they get them wrong. That don't make sense. Half your fraction can't be negative, the whole thing got to be negative. Alright, moving on. Slope-intercept form. So equations of lines. Most linear equations are written in slope-intercept form or standard form. Slope-intercept form, everybody should know. But we're going to write up. Y equals mx plus b. In that equation, the m represents our slope. The b represents our y-intercept. Y-intercept, where our line touches the y-axis. These are the two things you need to write a slope-intercept form equation. And if you can write a slope-intercept form equation, that means you're going to graph a line based off of it too. You should be able to work both ways. Alright, given the graph, write the equation in slope-intercept form, number 10. So they want me to pull the information off the graph and write a slope-intercept form equation, which isn't hard to do. First thing I always get, and I label my stuff too. So we're telling you if there are the two things you need to write a slope-intercept form equation. You need your M and you need your B. I always grab my B first. So up here I'm going to label, I'm going to say B equals, and I'm going to tell what B is. B is my y-intercept. B is where my line intercepts the y-axis. At what point does my line intercept this y-axis? Go ahead, Jalen. 0, -3, that's the coordinate. So, but you only need the y value though, because the x value is always going to be 0 anyway. -3. So at -3 on this graph, y'all should see that's when my point hits the y-axis. Now you can write 0, -3 if you want. Just understand you're not going to use the 0 part. But I will put that down here on here, that this is at 0, -3, so y'all know. And then so our y-intercept is at -3. And then after that, we need to know our M, our slope. Since it's on the graph, we could just count it. And now, like I said, they gave me 2 points, so I'm going to use those 2 points. But if you see a shorter way or a shortcut in between, you can use it. Every kid don't see that, so I'm going to just use the points if they give me points. So let's kind of color outside a little bit so you can see my actual triangle that I'm making. Going up, going right there, going over, I'm going here. All I'm doing is counting for my slope. So my rise was 1, 2, 3, 4. My run was over 1, 2. And my line from left to right is going up, so this is positive, yes? So this is 4/2 for me. Rise over run, so the vertical over the horizontal. But you know that can be simplified. 4/2 can be reduced down to what? 2/1. Y'all should all know how we did that. I shouldn't have to do the division on that. Y'all should know. So my slope for this one is 2/1. Now that I have my B and my M, I can write my equation. Jalen, what equation am I about to write? Y equals 2/1x. Plus what? That's the only thing. The plus sign is definitely here in your equation. But if you have a negative number, do you have to write plus -3? No, just put a minus sign there. -3. Now, if you write plus -3, I don't think we'll mark you wrong, but it's just not necessary. Why write plus minus when I could just write minus? If your sign is negative, then it's going to be minus anyway. So that's how you write it. Or if you want to clean it up, if you're just writing the equation out, because sometimes you'll see them like that, you don't have to have the fraction. If it's a over 1 situation, you could drop the 1 and just write 2x minus 3, because that may be the way you see it sometimes. Either one would be good for me. Either one would be right. It's just when you're getting ready to graph, you need to know that it needs to go back to a fraction. 2/1. Number 11. That's for y'all. Find B. And then find M. Find B and M, and I'll help you write the equation. Let them do it first. Looks like y'all might be ready for the most part. Billy, what you get for B? Girl, what did you get for B, your intercept?
Oh, 0.
B was at 0 because it was at 0, 0. What'd you get for M? Yeah, she said she got -1/3. Why? Because she went down 1 on here. Because this rise was really a fall. She went down 1 because this line is dropping. Y'all should see that. And then she went to the right 3. Now, one thing I would say, we always, when we graphing, and I don't think we graphed no lines today. I need to print that out. We need to do graphing practice though. Well, whenever we get there. Whenever you're graphing a line, you always run to the right unless you can't run to the right. There'll be a couple situations that you run into where you can't go to the right. And I'll show y'all that. I'll probably print that sheet tomorrow. I don't know why we didn't get that. But yeah. So like Billy said, slope is -1/3. You can't reduce that, so that's good to go. It's ready. What equation, Billy? Y equals, what's the slope intercept form equation? Billy?
Yes.
What's the equation?
Oh, y equals -1/3.
Plus what?
0.
That was a trick question.
I did.
Yeah. So if your intercept is 0, there's no reason to write +0 at the end. That's purposeless. That's why if you ever see these slope intercept form equations and there's nothing after x, that means your intercept is where? At 0. If you ever see your equation and you don't have nothing after your x, that means your intercept is at 0. Because there's no reason to write plus or minus 0. Alright. At the bottom, last couple. Determine whether the equations are parallel, perpendicular, or neither. You see we start using the symbols down here too. So you get two slope intercept form equations. Number 12 is easy because they're already in slope intercept form. So all you got to do is determine whether these two equations are parallel, perpendicular, or neither. Lucas, what's the slope on this first equation? Y equals 5x plus 5. It don't matter. I mean, okay. That's not a hard question to answer, though. Jordan, what's the slope on this equation on number 12? Y equals 5x plus 2. Say it again. I just want to know what the slope is. Thank you. 5 over 1. How? Because in the slope formula it said m represents the slope. So m for me would be 5. Remember, when we pull it out, we need to write it as a fraction like Jordan did. Jordan, the second equation, 5x plus 1, y equals 5x plus 1. What's the slope there? Yeah, it ain't no trick question. 5 over 1 as well. That's the case, Jordan. What kind of lines you got here? These two lines are parallel. All you gotta do is compare slopes to figure out if lines are parallel, perpendicular, or neither. Number 13. I try to mess with you a little bit, but the situation is still the same. Emerald, what's your slope for this first line here? Y equals negative 3 over 2x plus 4. Yeah, first slope will be negative 3 over 2. What's the slope of the other line? Emerald fell for our trick. A lot of y'all will too. Now, Your slope is always m. M is always in front of what variable? X, right? So on this one, they just wrote the intercept in front and the slope in the back. But the slope it'd be easy to identify because it's always going to be in front of X. Alright. So on this one, and if you don't have no X in your equation, that's one of those situations where you either at zero slope or undefined slope, and that depends on whether they say y equals 0 or x equals 0. That it's going, but you'll notice that difference in that equation. But on this one here, we have a slope is 2 over 3. Based on the two slopes they gave us, what would y'all say those lines are? Perpendicular. I wrote that sloppy again, my bad. Alright, here's what I need to get you to. Down here, make it a little tougher. Can't just go to thinking you know what to do on this one. I'm gonna color code on this one too, because I'm do two different things. We gave y'all space for a reason on this one. So on number 14, I got two equations of lines here. This first one is in slope intercept form. It's y equals negative 0.25x minus 5. This one is in slope intercept form. Only issue is I got a decimal here. And we need to show y'all this because y'all need to know how to do this. Before I can compare these two, I definitely need to turn this decimal into a fraction so I can get a fraction slope. Anybody know how to turn a decimal into a fraction? Uh-oh. Huh? Yeah, but how would you convert it? The kids don't know how to get there because a lot of kids don't know that's a quarter. That's fine. Okay. So since y'all so smart. I get that. How would y'all do 0.35 then, since y'all know so much?
But you divide it by 100.
Huh?
So you divide it by 100.
Well, that's what I want to know then. Thank you. Yeah, y'all could do a quarter easy, but I was do something that ain't a quarter. Y'all ain't gonna know if you don't know how to convert a decimal. So, like he said on this one, to convert this decimal to a fraction, he's gonna divide it by 100. Why? You should ask why. What place is this decimal in? The hundreds place, right? The places tell you what to do. If it was in the tens place, if it was just 0.2, I would divide by 10. But since it's 0.25, it's in the hundreds place. Out to the side here, I'm gonna say on top, negative 25 divided by 100. And then I need to reduce that. Reduce it by 25. You know 25 goes into 100. So you get negative 1 over 4. So I know my slope in fraction form is negative 1 over 4. Alright. That being the case, then my equation itself will change to y equals negative 1 over 4 x minus 5. So that's what I'm going to use for my first equation. Instead of that 0.25, I'm looking at this. My second equation over here, my issue is I can't see my slope because this isn't in slope intercept form. This equation is in standard form. But once again, this is an algebra thing too. You should know from algebra how to move an equation from standard form to slope intercept form. To do it, all you do is solve for y. And you got two variables here, but I'm just going to solve for y. Solving for y is just going to have me moving everything to the other side of this equation. Alright, this is where kids start to get thrown, so I'm a little worried, but whatever. On this equation, I'm solving for y. First thing I want to do is move this 2x to the other side. is a positive 2x, so to get it to the other side, I'm going to subtract 2x from itself, and then I'm going to move it to the other side of this equation. When I move it to the other side, though, I'm not going to put it under 56. Why would I not put 2x under 56 if I'm subtracting? Thank you. I like what you said. Could have been said a little bit better, but yeah. She said 2x is a variable and it's not the same. They're not like terms, right? I can't put those together I can't subtract 56 from 2x. Y'all should all know that. So when you move it to the other side, you're going to move it. I always put it out to the side so y'all can see I'm not putting those together. Now, I'm canceling this right here. I'm bringing down what's left over, which is a positive 8y. So I'm bringing down positive 8y equals, on this side. Now, I could put the 2x at the end when I write this, but y'all know slope intercept form says y equals mx plus b, right? So I want my variable in front. So I'm going to move it out front when I do it. I'm going to move it here, negative 2x, and I'm going to put positive 56 on the end. Plus 56. Now I've only did one thing. Y'all shouldn't be confused. Are y'all confused? Anybody confused? All I've done so far is move 2x to the other side of the equation. I just feel like some kids are going to freak out on this when this is regular algebra. It's something y'all should already know too. Y'all should have did standard form equations and y-intercept form equations last year. On slope intercept form. So from there, the last thing I need to do is divide by 8. Now, since I'm dividing by 8, division, everything is getting divided by 8. Like, you could put one big line over here and put 8, but I like to split it so y'all can see y'all turn separately. Once I divide by 8 on this side, everything on this side needs to get hit by 8. Here and here. Everything over here needs to get hit. Cancels here, leaves me with just y. That's what I want. I want y equals. On this side, let's try to do this without doing a whole reduce thing. What's negative 2 over 8 reduced? Huh? No. 1/4. Negative 1/4. You divide by 2 on top and bottom, you get negative 1 over 4. Y'all should know that. X. And then over here is positive 56 divided by 8. I don't know what that is. What?
6, 7.
I'm about to say 6 or 7. It's 7, ain't it? Yeah, it's 7. Alright. So this is my other equation in slope intercept form. So these are the two equations we need to be comparing on this one. Y equals negative 1 over 4x minus 5, and then y equals negative 1 over 4x plus 7. Now that they're both in slope intercept form, I can tell you what the lines are. Are they parallel, perpendicular, or neither? Not everybody at once. What? Parallel. But the slopes are the same, they gotta be parallel. I want y'all to try that one. On 15, you are moving, well, you solving for y on both of them. You got to get both of them in standard form. Once you get both in standard form, tell me what the lines are, whether they're parallel, perpendicular, or neither.